Good evening, ladies and gentlemen, and a very warm welcome to the design reveal of Delft Hyperloop. Tonight, you will be the first to finally see what we've been working on so hard for the past few months. My name is Peter Becking, I'm the team captain of this team, and my responsibility within this team is to be the main point of contact for the outside world and to keep everyone in the team with their noses in the same direction. Besides that, it's my job to make sure there's enough resources for the team and to make sure that those resources are divided in the best possible way to make this year a success. Together with Sittard, Nina and Gijs, I will guide you through the evening of showing our design. But before we dive deeper into our designs, I would like to take you back in time to about a year ago. The CO2 emissions were rising and rising and rising, and the transportation sector was one of the big contributors. But then, when the whole world got in lockdown and all transportation was put on hold, also something great happened. The CO2 emissions dropped, and there were cities that saw clean air for the first time and had their smog removed. What if I tell you that there is a solution to keep that smog away and have these cities clean air forever? Well, that solution is called Hyperloop. And here's how it works. The pod, the passenger module, travels in a tube. And not only does that tube protect the system from all external effects, there's also a near vacuum in the tube, which means there's almost no air particles, so also almost no air resistance for the Hyperloop to travel. The Hyperloop will never suffer from headwinds like planes do. Also, the Hyperloop is propelled with magnets. There are coils in the track and permanent magnets on the pod, and that way the Hyperloop rides a contactless magnetic wave to its destination, just like a surfer in the water. Also, the Hyperloop is levitated by magnets. And these magnets are so strong to keep the Hyperloop pod and its passengers inside safely in their place. So, this lack of resistance of air, and also the fact that due to the propulsion and the levitation, there's no contact with the ground, the Hyperloop can reach extremely high speeds with very little energy. So, now that you know how the Hyperloop works, I would like to ask you a question. What is it really that makes the Hyperloop such a promising mode of transportation? Is it about getting from A to B extremely fast? Is it about minimizing energy losses? Or is it about being extremely safe? Well, the Hyperloop is all of those. But the way I want you to see Hyperloop from tonight on is that it's a world-changing mode of transportation. We will bring cities closer together so that the citizens of continents will live up to the full potential of that continent. Because traveling at 1,000 kilometers an hour is indeed very exciting, but it really brings people together. Imagine that you can just go and quickly visit your friends in another country and be back before lunch. You can be back just in time to continue your normal workday as you would after a year or maybe a week of vacation. Imagine there's an organ to be transplanted in Amsterdam, We can transport it with the Hyperloop to Paris and save a life in a local hospital. And imagine that while we're improving our lives this way, we're also saving the planet. We can reach our United Nations Sustainable Development Goals while improving our way of living. Do we really want to go back to the emissions of before the COVID crisis? Well, we don't, because we believe in a future with Hyperloop. And that is what brought us as a team together. We are 39 extremely motivated students of the Delft University of Technology with one common vision: being part of that future. And tonight, we will not only show you our designs, we will show you that the Hyperloop is not just a concept anymore. It's getting real.
It's actually quite remarkable to sort of see this in operation. Amazed at what the student teams have done. Really just blown my mind, and may the best team win. Yeah.
The other categories, and that's Delft.
We're going to share it in 5, 4, 3, 2, 1.
So, this year, with this amazing team, we decided to take a big leap in the advancement of Hyperloop technology. The student Hyperloop environment has been solely focusing on speed since a few years ago. But we believe you need more than a one-sided vision in order to create such a complex system. This year, we decided to shift our focus and come up with new goals. And I'll give you a hint, we are not focusing on speed this year. Because we are doing things differently. The Hyperloop is a long-term solution. Decades after the implementation, it would still be the best mode of transportation. But to achieve that, the technology should be at its finest from the start. You have to take all future complications into account to really make steps towards the Hyperloop as it will be implemented. And this vision to the near future is what inspired us to start the plan. To plan to build a system that is ready to be upskilled and implemented into the real world. To really start to use those techniques that come with the Hyperloop idea and transform that idea into a working system. And that is how our goal was born, to build a scalable Hyperloop. And we will take that Hyperloop to Valencia this summer. We will compete in the European Hyperloop Week against all universities all over the world to show that we did the best job. And I'm pretty confident we will not go home empty-handed. Because we, ladies and gentlemen, have a winning strategy. And that strategy consists out of three things. These three things helped us in our design process and will help us in Valencia to get that trophy back to Delft. First, imagine you would develop a Hyperloop. You would probably like it if people would use it eventually. And in order to convince those people to use your Hyperloop, it should bring them to their destination in a safe way. Also, these people should arrive at their destination without delay. And that's why, in our design process, the first thing we focused on is reliability. That's why we included a fail-safe braking system into our pod to make sure that if something goes wrong, the pod comes to a safe standstill and will not crash. Secondly, the world we live in now is running out of resources. And we understand that a Hyperloop network would require some of those resources. In our design, we've always made sure to minimize the use of those resources. The second thing we focused on is sustainability. That's why we are 3D printing our aeroshell out of sustainable and environmentally friendly materials. Then, last but not least, one of the big advantages of a Hyperloop network is its lack of energy losses. If you want to upscale and increase the capacity in a cheap and easy way, the system needs to be as energy efficient as possible. That's why we chose to go for a linear synchronous motor this year. It is a magnetic, contactless propulsion system known for its extreme energy efficiency and eventually high speeds. And this, ladies and gentlemen, has been our golden triangle for our design process. To come up with a scalable Hyperloop. And it was not always easy. But luckily, we are not the only ones that believe in the urgency of changing the transportation sector. Our partners have been extremely valuable for us in our journey. And I know that you are all watching, so I'd like to thank you tonight to support us in so many different ways. Financial means, materials, expertise, equipment, tools, software, and so much more. And we are, of course, always looking for more partners to join us in our journey to make Hyperloop a reality. So, with an amazing team of motivated and bright students, a winning strategy, and a great set of partners, we've been developing our prototype. And I am very proudly presenting to you tonight a first glimpse of our final design.
Wow, that was just absolutely breathtaking. I don't know how to express myself. My earliest memory of Delft Hyperloop was the SpaceX Hyperloop pod competition, where I was truly mesmerized by the intellect and innovation of the first Delft Hyperloop team. It was in fact because of Delft Hyperloop that I cognized the existence of the Delft University of Technology, where I'm currently pursuing my bachelor's degree in aerospace engineering. I am Siddharth Manoj Nair, the head of operations for Delft Hyperloop this year. My responsibility in the team is to work with the business and the engineering departments to set, and more importantly, meet deadlines in order to ensure that we have a functional Hyperloop pod prototype in time for our competition this year, the European Hyperloop Week. Time. In my opinion, the most valuable, intangible element in existence. One of the most crucial aspects that contribute to the victory of a team is the successful management of time. The onset of the coronavirus truly grounded mankind. While we endured the hardships that accompanied the virus, a truly beautiful outcome of the same was the appreciation of those aspects that we did not particularly know the value of or care for before, the most important of them being time. The coronavirus adversely affected millions of people around the world, making it difficult for them to do what is necessary to survive. The situation of Delft Hyperloop was no different. Unlike the teams from the previous years, we not only started with less than a third of our workforce, but with only 9 months in hand. While our goal of being a team that not only organizes an international Hyperloop event, but at the same time develop a linear synchronous motor, which is truly one of a kind, we knew we had to give it nothing less than our very best. And that is exactly what we did. We pulled ourselves together and decided what milestones we had to achieve and by when we wished to achieve them. From planning every aspect of the design to the minutest of details, to pulling all-nighters one after the other, this team has truly given it their best and gone out of their way to deliver in time with absolutely no compromise being made with respect to quality. Everything was going fine. All was good. But no one can predict the future. It was in the month of February that we, as a team, faced a major setback. Panic-stricken, we were suddenly unsure if we would make it in time for the event, or at the very least, if we would have a functional Hyperloop pod. Moving nearly 2 months into the future, today, the 26th of March, through sheer determination, strong will, and an exquisite eye for detail, I can say that we've successfully averted the crisis. In addition to the same, I can also say that we're currently in line with our planning and will most certainly finish in time to not only participate, but win the European Hyperloop Week. We are doing things differently. While Delft Hyperloop obviously maintains the status of a student design team, we're much more than just that. We are a group of highly motivated individuals dedicating our time to developing the Hyperloop system and involve ourselves in activities that help bring the Hyperloop community together and help make the Hyperloop concept a reality. A few examples of the same include the research studies performed by our scalability department, our participation in the Hyperloop development program, or even our participation and organization of the European Hyperloop Week. Well, I've been going on and on about the European Hyperloop Week, but what exactly is it? After the discontinuation of the SpaceX pod competition, the very future of the Hyperloop concept was brought to question. There arose the need for a platform to propel the Hyperloop concept forward. The European Hyperloop Week is that platform. The European Hyperloop Week came to exist with the coming together of 4 of the best student Hyperloop teams to organize a competition that not only allowed innovation to take the driving seat by promoting healthy competition, but also by helping to bring together Hyperloop enthusiasts from all over the world to interact with one another and connect, truly contributing to actualizing the Hyperloop concept, helping in making it a reality. The European Hyperloop Week will take place over the summer in the beautiful city of Valencia. Between the 19th and the 26th of July, the city will host more than 600 participants from over 20 countries, 20 different student teams hailing from 10 different countries. Throughout the course of the week, we will have multiple major Hyperloop or Hyperloop-related parties share their expertise and knowledge to not only the participants, but also the general public, who will have access to the event. In addition to the seminars and workshops that are set to take place, the participating teams will be given the opportunity to showcase or demonstrate their work, which will be assessed by the technical jury of the European Hyperloop Week. Being both organizer and participant of the European Hyperloop Week, the 4 organizing teams thought it was a must to have an external, unbiased jury fairly assess the designs and research presented by the teams. It is for this reason that we have an exceptionally competent technical jury that is comprised of engineers and specialists from a multitude of relevant or closely associated fields. As I stated before, it is this technical jury that will evaluate the work presented by the teams and decide the winners of the 6 award categories of the European Hyperloop Week. These 6 categories are the mechanical subsystem, propulsion subsystem, levitation subsystem, and electrical subsystem awards, the complete pod award, and finally, the full-scale award. This year, Delft Hyperloop will compete in 5 of the 6 categories. The mechanical subsystem award, where we will showcase our structures, suspension, and braking subsystems. Our propulsion subsystem, where we will showcase our one-of-a-kind linear synchronous motor. Our electrical subsystem, where we will demonstrate our ability of pod and trackside localization. The complete pod award, where the work of every engineer will culminate to demonstrate a reliable, sustainable, scalable, and energy-efficient Hyperloop pod structure. Finally, the full-scale award, where the hard work of the scalability department will be reflected and presented to the general public and the technical jury through the design and research performed by the team. Now that you have a sound understanding of what goals we aim to achieve during the European Hyperloop Week, it is my honor to call upon stage Nina van Pol, the project executive of Delft Hyperloop this year, to tell you who will be achieving what goals.
Thank you, Siddharth. So, we decided to strive for winning multiple awards in all these different categories. But with whom exactly were we going to make these goals into a reality? When we started on our Dream Team experience at the beginning of this academic year, the first thing we had to decide was what we could contribute to the world of Hyperloop with the 9 months that were given to us. It's difficult to say why we chose what we chose to do. Perhaps we wanted to live up to the legacy of previous teams, or maybe it was what we all really came here for in the first place. We had decided to develop a full Hyperloop pod with a working linear synchronous motor and compete in 5 out of 6 different categories of the European Hyperloop Week. Our goals were questionably high, because the reality was that in mid-October, we were just a team of 12 people with only 2 full-time engineers. One could hardly call us a team even. We were more like a collective few fanatics with comically high ambitions. And I think I speak for all of us when I say that our goals cost us all multiple sleepless nights. But I guess half the fun of this project is accepting a challenge like you've never done before. And this is undoubtedly the case for us. But in order to swing into full action, we needed a bigger team. Now, from mid-October to November, our team was pretty desperate for help. All our team members were consumed with trying to move this gigantic mountain in our limited time. For a whole month, we were determined on creating and expanding a fuller team. Our engineers were simultaneously fixated on coming up with concepts for each subsystem. And I remember my team members coming up to me, expressing concern about the work that they were required to do, how they could not possibly manage this crazy project schedule with their masters. And I was feeling guilty for the stress that this project was causing them. And I told them that they wouldn't have to work like this for much longer, and we were making sure that help was on its way. But with every day that passed, our spirits got lower, and the frequency of questions regarding new team members got higher. Then finally, December 1st arrived, which brought us regained energy and prospect, because we had managed to pull together a full team of 39 team members, and we felt like we could properly start. Before any of our team members, our new team members, had even set foot inside our office, I'd already instructed that they get to work. And from that moment onwards, none of us has had a chance to take a breath. Every single one of us has been working relentlessly, day and night, in order to materially realize what we believe in. And the four of us feel so thankful towards all of them for putting in all their effort, particularly in light of how difficult this past year was because of coronavirus. I proudly present to you today the team members of Delft Hyperloop V, a team consisting out of 11 different nationalities and 12 different academic backgrounds, making it the most diverse team that Delft Hyperloop has ever seen. I am glad to spend all my hours with them, and I feel thankful for the opportunity to learn from them every single day. My name is Nina van Pol, and I am the project executive of this team. I'm the primary point of contact for our team members, and I'm responsible for the motivation of this team. Tonight, I will tell you more about our team, how we work, and what our vision on the implementation of the Hyperloop is. Now, our team members have not been able to socialize and team bond in ways that we would have wanted to, which I know that we have deeply missed out on. The conditions that COVID has made us work under are so different from how it used to be. Some of our members have been or still are in another country. They've been working with people that they've never met in real life, and one of them is not even sure if the travel situation will allow for him to join us for the competition. I am in awe of their dedication. People join Delft Hyperloop because they are fascinated by the concept, but also because they want to build something from scratch by team effort. For the past couple of months, I have given my best to bring our team members closer together and motivate them in order to bring this project to a success and win the European Hyperloop Week. Now, one of the assets that I value the most in our team is the informal and fun vibe which is always there. We have people from different cultures with differing norms and values, which are not always apparent to one another. But our team members feel as though they can always be open about these different customs as such, and one feel as if it's always okay to politely ask. We can joke with each other and of our differences in a caring manner, and this creates an atmosphere in which people feel acknowledged and respected. After all, we do have much in common, because we are all students and we are all eager to learn anything that comes up our path. Now, working online has definitely been something that me and my team members have been struggling with. For example, how would I create a situation in which our propulsion engineer and design engineer have a good heart-to-heart? I figured I could bond people out of different departments who usually do not work together and put them in a crazy 10-minute break. And during these 10-minute breaks, I would organize weird and wacky games that put people outside of their comfort zones and have a bit of fun. And this is how I subsequently found my propulsion engineer dancing in front of his laptop in a very interesting manner in order to mimic Nicki Minaj to our design engineer. Our design engineer correctly guessed it was Nicki Minaj, and I genuinely hope that my team members have enjoyed and have laughed as much as I have during these 10-minute breaks. Because we are doing things differently. There's another anecdote that I would like to share with you all. For the production of our linear synchronous motor, our propulsion department was given the opportunity to make use of production facilities in the south of Holland. And it became clear that a lot of production would need to happen at this location itself. In order for the LSM to eventually work, we estimated that our propulsion department would need to completely move for 4 months. And this would start from that next week onwards. We had booked their Airbnb before we'd even properly discussed it. In this rush, we had not considered the fact that our engineers might not be open to moving cities for 4 months. We met with them with our tails between our legs, apologizing profusely for our rushed thinking and not taking their lives outside of Hyperloop into account. They couldn't be bothered, because they would do anything in order to make their subsystem work. And this example is just one out of many that shows the endless dedication and commitment that our departments have for our team. Now, our team consists of the following departments: business, scalability, and engineering. Our business department is responsible for maintaining close relations with our partners. They provide our team with any external help that we need. Without them, none of our ambitions could be realized, and many of you would not be here today. Now, developing the Hyperloop technology is one thing, but the realization is another. Have you ever thought of all the steps that need to be taken in order to make the Hyperloop system ready to be used by you and me? Our scalability department contributes to the realization and standardization of the Hyperloop itself by making scalable designs and conducting valuable research. For the first time since Delft Hyperloop history, we are competing in the full scale award with our team. Our public relations managers are responsible for the display of our designs at the European Hyperloop Week. They are also in charge of the presentation that I am giving to you right now, and all other communication to the outside world. Now, to tell you more about what our scalability department has been working on, I would like to take you with me on a Hyperloop ride. Imagine being in a Hyperloop pod, traveling from point A to B. For the infrastructure network of the Hyperloop, there have to be tubes. And these tubes can be above ground on pillars, as you can see right here, but they could also be constructed right on top of the ground, or even underground in tunnels. Now, these three options have many different advantages and disadvantages. And these weigh differently according to a specific location. Now, our full-scale engineers are developing a framework in which enables one to decide for the preferred type of track for any given location. So now we've been traveling through these tubes, and we reached the station. But where would this station be located? Many Hyperloop organizations envision the Hyperloop station to be similar to present-day airports. They are being built in the outskirts of the city, and they're spaciously designed with a massive surface area. Now, designing a station like this with little construction requirements and unlimited space is easy. Yet, this is not how we envision the Hyperloop station, and it's not what we are aiming for, because we don't want to have to awkwardly commute to our Hyperloop station in order to access. We envision the station to be similar to a present-day train station, centrally located, connecting densely populated areas and making efficient use of limited space. Because we believe in connecting cities and therefore connecting people in a sustainable manner. Now, our design engineers, they envisioned their station to be the pivotal entrance to our country. They want it to be the first sight of the Netherlands for any tourist, citizen, or businesswoman. The district of Amsterdam South is currently under mass expansion and development. And therefore, it's becoming more and more integral to the beating heart of Amsterdam. Therefore, our design engineers are taking up the challenge of designing the station right on top of Amsterdam South train station, a prime location in our capital city. Now, as you can see, the future with Hyperloop in it is not so far away anymore. Our team has been iterating our designs and covering all aspects, because we want the world to be as ready for the fifth mode of transportation as we are. The Hyperloop system that our engineers have been working on for the past few months is now ready for the world to see. And with great joy, I present to you tonight the design of Delft Hyperloop V.
I have looked at this design so many times the past couple of months, and still, every time I see it, I'm amazed by what we have accomplished in the past few months. My name is Gijs van Veen, and as the chief engineer of Delft Hyperloop, I am responsible for the technical quality of this Hyperloop prototype. And today, it is my honor to present to you the details of the technical design we have made in the past couple of months. And as my colleagues discussed, this year we have a new team, a new competition, and a totally new goal: to build a scalable Hyperloop. And with this goal came our golden triangle with reliability, sustainability, and energy efficiency. And throughout my presentation, I want you guys to notice that each department is contributing to a bit of this triangle, and in the end, making them come all together to form the scalable Hyperloop that we envision. So, how did this new vision, this new goal, change our design process? Well, if we look at the design of previous years, we can see they all have one thing in common: the track. But we thought, why limit yourself to the I-beam? No. This year, we are doing things differently. And to achieve this scalable design, our team is divided into different departments. And at the very heart of those departments is the propulsion department. They are responsible for providing the thrust force necessary to accelerate the pod. And with this addition of the track design, it allowed us to look into far more options than before. We did extensive research, and in the end, we found the best method for the eventual Hyperloop, the linear synchronous motor. And why is it such a good option for a Hyperloop? Well, to show you, I want to compare it to other modes of transportation. For example, an ordinary car, which can reach efficiencies of up to 20%. And next, we can compare it to an airplane, which can reach efficiencies of up to 50%. But with our linear synchronous motor, we are easily able to reach efficiencies of over 80%. Well, let's have a look at this linear synchronous motor. Here you can see a render of the linear synchronous motor. And you see coils and magnets. Those coils are embedded into the track, and those magnets are on the pod. And they interact with each other to create the thrust force necessary to propel the pod. And they do so very efficiently. And all is good. But this LSM brings a big, big challenge. It is insanely complex to design, produce, and test such a motor within 1 year. And to show how complex this whole design process is, I want to take you all on a journey. The journey of a single component of this whole assembly, the coil. So let's zoom in on the coil. We are going to design and produce the coil of our Hyperloop system. But where do we start? There is so much to consider when we are designing a coil. We need to decide on which wire to use, which thickness it has, how many turns we need to make it, and the configuration of the coil. We can make a coil with or without a iron core. And we can vary the amount of turns by making it wider or thicker. And in the end, all these parameters have a massive influence on the performance of our motor. For example, let's say we want to increase our thrust force. So we add a couple of turns to our coil. This way, we need a longer wire, increasing the resistance of the system, requiring more power, and ultimately lowering our top speed. So, after months and months of designing and simulating every possible configuration of these coils, we finally got it, the end configuration of our coil. We were ready to start a new phase, and we were going to produce. But how do you produce a coil? It's just a wire wrapped around something, right? Well, that's what we did as well. And let me show you the result. I can honestly say, this was not the biggest success of our year. But how do we produce such a coil? With hundreds and hundreds of turns that can fit within the palm of my hand. The setup we used before is not going to be enough. No, we need a special machine, the coil winding machine. And this machine requires specialized tools for our specific coil. And then in the end, we did it. We selected our wire, we made our custom designed coil, and we had our specialized tools for the coil winding machine. And then we got it, the first batch of our coils. And I gotta tell you, this was such a great feeling. The first batch of coils. But these coils are only a single part of an assembly. An assembly with hundreds of coils with enough wire to reach the cruising altitude of an airplane. An assembly with magnets strong enough to lift an elephant. And an assembly fully integrated into a track and pod design. Just imagine the complexity of designing, producing, and testing such a motor. And in the end, this is the marvelous result. You can see the coils embedded into the track, which are coated with a special epoxy. And you can see the yoke, which houses the magnets, which are necessary to provide the thrust force. And besides this physical design, there is a complex feedback loop that makes sure the coils are powered at just the right time. And if this timing is off by even a millisecond, the coils, we not only lose the efficiency we talked about before, but we could also start decelerating instead of accelerating our pod. But in the end, we managed to do the impossible. And we have designed the first generation Delft Hyperloop linear synchronous motor. An achievement we are immensely proud of. But with only an LSM, we are not going to win the EHW. No, we need a whole pod. And the very foundation of our pod is formed by the structures department. They are responsible for providing the thrust force. They are responsible of designing the chassis, which is supporting all other subsystems and transferring all loads during a run. And during the design, to make it scalable, they focused on two things: using sustainable materials while still being as strong as necessary. And man, they did an amazing job. Their chassis is made out of aluminum beams, which is one of the most sustainable materials there is. It is mounted together with brackets and reinforced with special stringers. And it is very strong. So strong, in fact, that if all members of the department were to sit on one end of the chassis, it would only deflect by a single millimeter. Next thing we need is a way to have our pod follow the track. And this is the responsibility of the suspension department. And the suspension department has two main focuses. Firstly, they smoothen out the imperfections of the track. And secondly, they make sure that the movements of our pod stay within a certain limit. So let's look at these imperfections. And although they might seem small, they pack a punch. You could compare it to driving on a highway at 100 kilometers an hour and hitting a speed bump. Not very pleasant at all. But with their new system, they do not only smoothen out these imperfections, but they do something even more important. They make sure that the movements of our pod stay within a certain limit. And why is this important? Well, to show you, I want to take you to the front view of our vehicle. And as you can see, there is a certain distance between the magnets and coils. And for our LSM to perform properly, this distance needs to be maintained. And with our current design, the movement of our pod stays within 2.5 millimeters. Okay, so now we have a pod and we can propel it and have it follow the track. But in the end, there is always something that can go wrong. And then we need to come to a stop. This is where we enter the braking department. They are responsible for designing the emergency braking system of the eventual Hyperloop system. And to make it scalable, they focus on having it reliable and fail-safe. And man, they did. With their system, they are able, no matter what happens, if a brake pad fails, if there's a leak inside the system, or even when complete power is lost, they are still able to bring the pod to a safe stop. So how does it work? By increasing the hydraulic pressure behind the brake pads, they get slammed onto the track, inducing large friction forces that slow down the pod. And they do so effectively that we can reach a deceleration of 3G. That's 10 times as fast as a normal car can decelerate. So now we have a way to propel our pod, have it follow the track, and make it stop. But on our own, all these systems do nothing. We need a way to control them. And this is where the Sense and Control department comes in. And the Sense and Control department does two things. They gather information from all over the pod and use it to control the pod. And they gather all kinds of information. You could see pressure data, battery status, and the location of the pod. And this location of the pod has got an extra requirement this year, because for our LSM to work properly, it needs to know the exact location of the pod at all times. And with their new system, with sensors embedded into these white boxes on the track, they are able to measure the location of the pod with an accuracy of millimeters. And with this data, they can control the pod. You can really see it as the brain of the system. And it is easy to control normal, expected behavior. But what happens if something goes wrong? Say, for instance, a coil heats up and gets too warm. Then this unit needs to shut down. Or the pressure inside of the braking system starts dropping. Then the pod needs to come to a stop on its own. The software on board of the sensor control department makes sure all of this happens within a split second by being fully autonomous. So now we have everything we need. We can accelerate our pod, guide our pod, brake the pod, and we have a way to control all of this. But in the end, when we power on our pod in Valencia and it passes, this is not what you're going to see. No, what you're going to see is the aerodynamic shell designed by the structures department. And the aerodynamic shell has two functions. Firstly, it protects the subsystems which are underneath. And secondly, it improves the aerodynamic performance by reducing the drag, further increasing the efficiency of this whole system. And this aeroshell is sustainable as well. It has been 3D printed of a fully recyclable material. So this, ladies and gentlemen, is the new Delft Hyperloop prototype that is not only going to be an award-winning machine, but will show that the Hyperloop is getting real. Ladies and gentlemen, thank you for your attention tonight. Now we will show you our design one more time, and afterwards we are available for questions in the Zoom chat. Thank you.